In today's video, we will be exploring the beginning of chapter 14, that is the chapter associated with the chemistry of polymers. And so we have to start off this chapter by really defining what a polymer is. And polymers can go by a number of different names, macromolecules or polymeric substances. There's a branch of science known as material science that deals with polymers and some other kinds of textiles and things. A polymer is just it's a molecule. It's a heavy molecule that has a lot of repeating units in it. The repeating units are called monomers. And where we see polymers the most often are in, again, the materials industry, plastics, synthetic fibers, things like nylon, rayon, Kevlar. We also see it in terms of things like rubber and foams. Polyurethane foams in particular are very, very common. Um, Things like carpeting, which use synthetic fibers for moisture wicking. These are all polymeric materials. They're all from this kind of of processing. Now, in terms of the types of polymers that exist, we can break down polymers into two different groups. The first group are what are called thermoplastic polymers. These are substances that when they are heated, they are softened. They will get soft, but when they return to a cooler temperature, they will harden back up. They'll go back to the way they were. And so the heating and softening and reforming stage is actually what allows a lot of these thermoplastic polymers to be molded into a bunch of different shapes. Because you can take the polymer, warm it, get it loose, get it to form whatever shape it is you want it to form, let it cool down again, it'll take the form that you want it to. And so where we see this the most often, these are our numbered plastics in particular. So we're talking about polyethylene, polypropylene, polystyrene, polyvinyl chloride, peat. These substances are your numbered plastics. These are the ones that tend to be the most recyclable, and you can see why they are recyclable based upon this description. We take them, clean them up, melt them back down, or at least soften them, and get them to reform and reuse. On the other hand, thermoset polymers, these are substances that once they've solidified, so once we get them to form, we can't remold them. So things like polyurethane, things like fiberglass, things like vulcanized rubber, once we make them, we can't unmake them without destroying their chemical structure. And so we find these a lot in consumer products. We find these a lot in fibers and more permanent kinds of applications as opposed to plastics. These are things that generally are not recyclable, or at least not in the traditional sense. Like you can take vulcanized rubber and grind it up and turn it into mulch or something like that. Um, but you can't take an old tire and help to make a reformed new tire out of it. Now, because of the nature of their composition, most of these things are hydrocarbon based, which means they are going to burn. And because of the other elements that are in there, they will generate some nasty gases when they burn. Because of their commonplace nature, we will find that polymers are in everything. And so most common fires are going to have some sort of polymeric material in them somewhere. Now, we can also talk about polymers in terms of classification based upon their use. And this particular breakdown kind of falls into the same place. Thermoplastic polymers, these are all plastics. These are polymers that can be shaped and can be formed. Again, all we need to do is warm them up to a certain temperature and they become much more pliable. Fibers are when we take polymers and we knit them into we weave them into threads or yarns, and then we weave the threads and yarns together to produce materials, textiles. So whether that's carpeting or clothing, fabric, what have you. Now, within this last set of fibers, there is a subset there of something called an elastomer. Elastomers are kind of interesting because what we see with elastomers is that these polymers are prone to being able to be stretched, but they stretch reversibly. So you can almost think of an elastomer in terms of its 3D structure as kind of like a coiled spring. And so if you stretch out a coiled spring, those coils can get further apart. So long as you don't stretch it too far, you know that the coiled spring will go back to its tensed up state once we release that tension. Once we stop pulling on it, it snaps back into to the way it was. And that's what an elastomer does on a molecular level. We can stretch it out, we can elongate it, and those coils will expand. But when the pressure is released, when the tension is released, they snap back into their original configuration. And so elastomers, common examples of these kinds of things are your spandex, your dry fit, your pretty much those fibers that have stretchy kinds of capability, elastics. In fact, elastics um, get their name from the elasticity that the molecules that are in them possess. Now, when it comes to polymers, polymers are so named because the prefix poly indicates that we have many of these substances. So the substances that are used to produce the polymers, the poly means that we have many of those substances. And the reaction that takes place is kind of an interesting one. It's something called polymerization. Polymerization is a unique type of chemical reaction. It does not occur in all things, but for things that have tendencies to be polymers, these kinds of reactions are quite common. And basically, um, polymerization is a three-step kind of process. There's the initiation stage, where something acts on the monomer to make it reactive. That's the first stage. The second stage is called propagation, and that's where the reactive monomer reacts with other monomers to make a chain. And then the third stage of this is um, conclusion stage. And this is where the reaction ends and chain becomes complete. And so this three-stage process, initiation, propagation, conclusion, this is how you can grow different polymer chains of different lengths. Now, the initiation stage, this is usually something that is inducted. So we introduce something, whether it's another compound that grabs electrons off of the monomers, um, or we introduce UV light, which can strip away electrons. Something happens to initiate the reaction by causing the monomer to become unstable and more reactive. Once we get to the propagation and conclusion stages, now we have molecules that are big enough that they actually start to create their own attractions to themselves. And so they can fold in each other, they can loop in each other, they can stack on each other and make some really interesting three-dimensional shapes. And the three-dimensional shapes that they make are have a lot to do with what kinds of properties they're able to exhibit. Now, when it comes to polymerization, there are two different types of polymerization, generally speaking. There is the addition polymerization. The addition polymerization usually involves molecules called alkenes. So an alkene is a hydrocarbon with a carbon-to-carbon double bond, and most alkenes fall into this pattern where we've got hydrogens attached to the carbons in 3 of the 4 possible locations. And then this fourth location is a wild card, and a number of different substances can be that R value. And so sometimes these are referred to as vinyl alkenes. So if you hear of vinyl chloride or vinyl bromide or um, uh, something along those lines, the chloride or the bromide, that's just what that R is. You take this R and you put in a bromine and it's vinyl bromide. You take this R out and you put a chlorine in and it's vinyl chloride. And these alkenes react with each other to make these really long chains where the double bond here basically becomes a series of single bonds, as those double bonds are used to create new attractions, new bonds between one alkene molecule and the next. Condensation polymers are a little bit different. Instead of the same molecule repeating over and over and over and over and over again, what we get are alternating polymers. And usually we see in there something involving an acid and or an amide. And what we're looking for there is a carbon with a double bond to oxygen and either another bond to hydroxyl group like this, that would be our organic acid. Or if we do a similar kind of setup and we have a nitrogen group here, that would be something called an amide. And so the condensation polymerization, what happens is these molecules will react, and as they do, they will drop off little bits. So we usually see the loss of the hydrogen here with another OH to make water, or we see the loss of the NH2 here to make ammonia. We get something along those lines. And so what we see is that this happens in one of two ways. The addition polymers are kind of like a freight train where all the cars are the same. We've got our alkenes. Our alkenes are going and sharing electrons, and they turn from individual alkenes into a large chain of single bonds. Condensation polymers, we see this alternating pattern taking place where we go from this molecule to this one, this molecule to this one, this molecule to this one. And what we end up getting here in this case is something called a polyester. And so this is what will conclude our introduction into polymers. Until next time, have a good day.